Welcome to this lesson session with Was Moses, a mathematics teacher. Today we'll be continuing the revision we started on solutions to GCE 2021 additional mathematics. Here we'll begin from question 26 because in the previous lesson we ended with question 25. We'll be looking at question 26 to question 50. Yes, please, before we begin, those who have not yet subscribed to our channel, please click on the subscribe button below to be part of this channel because there are still much more revision lessons installed so that whenever we are coming online or we prepare the lesson and send online, you should not miss it. We begin. Question 26. Two lines L1 and L2 are with gradients M1 and N respectively are said to be parallel if and only if the lesson will actually be by a presentation. We look at the solution. Given two lines L1 and L2, L1 with gradient M and L2 with gradient N, then we say that the line L1 is parallel to L2 if and only if M is equal to N. L1 is perpendicular, this is a symbol for perpendicular to L2 if and only if the product MN is equal to -1. In short, we are saying that when we have two lines, the two lines L1 and L2 can only be parallel if they have the same gradient. And for two lines to be parallel, the gradient or the product of the gradient of the two lines must give -1. Now, in this case, we are looking for the condition for which two lines are parallel. Therefore, if the gradients are M and M, N and M, then M is equal to N. And our answer in this case is B. We move to the next question. Question 27. The range of values of X for which the inequality -3 plus 2X is less than or equal to 5 is solution. -3 plus 2X is less than or equal to 5 if and only if we recall the basic laws of inequality. To remove -3, we add 3 on both sides. We add 3 on both sides. And when you add 3 on both sides, adding 3 here, see that 3 minus 3 will give 0. This 3 plus -3 gives 0, leaving this side with 2x, and 2x now is less than or equal to 5 plus 3, which means that 2x is less than or equal to 8. Now, we want the range of values of x. Therefore, these two should be eliminated from x. How do we eliminate a coefficient? We simply multiply by the reciprocal, and the reciprocal of 2 is multiplying by the reciprocal of 2 simply means dividing both sides by 2, and k should be taken here, please. I am dividing directly the inequality with 2 because 2 is a positive quantity, and I know that when I divide an inequality with a positive quantity, the inequality sign remains unchanged. So 2 into itself 1, 2 here 1, 4 into, no, please, we divide by 2. 2 into 2, 1, and 2 into 8, 4. So x now is less than or equal to 4. Thus, the range of values of x is given by the range x less than or equal to 4. Answer A. Question 28. The range of values of x for which the inequality 2x plus 3 into x minus 2 is greater than 0 is solution. 2x plus 3 into x minus 2 is greater than 0. Critical values, negative 3 over 2 and 2. Now, how do we get these critical values? Once a quadratic expression has been factorized into product of linear factors, if that quadratic expression was given an inequality, then to get the range of values of x for that inequality, what we do is that we apply the principle of factorization to get the roots. And those roots in this case will not be the solution to an inequality, but they will just be the critical values. They are called the critical values because they provide the boundaries to which each range of values of x can lie. Now, to get negative 3 over 2, we simply just apply principle of factorization and take this factor 2x plus 3 equal to 0. And when that is done, this will imply that x will be equal to negative 3 over 2, which is this critical value. Also, to get the critical value 2, we apply the principle of factorization here, which says that either 2x plus 3 is equal to 0 or x minus 2 is equal to 0. Now this one, x minus 2 is equal to 0, gives x to be what? It gives x to be equal to 2. So this value of x equal to 2 is this critical value. Okay, next. When we have the critical values, we can either use the table method or we use the number line to determine the range of values of x where the solution satisfying this inequality can lie. In this case, we've used the number line as shown. On this number line, this line is dividing at negative 2 over 3. This line is dividing at 2. Now, in the region below negative 3 over 2 is the region x less than negative 3 over 2. The region in between negative 3 over 2 and 2 is the region x is greater than negative 3 over 2 and less than 2, this region. The region above 2 is the region x is greater than 2. Now, we get a test value in each region. There are 3 regions. Substitute that test value into this product and note the sign of the inequality, or the product, not the sign of the product. In this region between, the test value we can conveniently work with is 0. Whenever you have a region containing 0, 0 should be your best choice. Take 0, 0, substitute for x, we have 0. Substitute for x here, we have 0. 0 plus 3, 3. 0 minus 2, negative 2. 3 times negative 2 gives a product which is negative. So that is why you have this negative, negative, negative. So which shows that all values of x, all values of the product we take here will be negative. Now, if we take a value of x in this region less than negative 3 over 2, let's take negative 2. Place negative 2 here. 2 times negative 2 will have negative 4 plus 3, negative 1. Negative 2 minus 2 is negative 4. Negative 1 times negative 4 is positive. That is why you see these positive values. In this region, we take 3. 2 times 3 is 6 plus 3, 9, which is a positive number. X is 3. 3 minus 2 is 1. 1 is a positive number. 9 times 1 we have 9. So the product is positive. That's why we have positive values here. Now, looking at the inequality, the inequality is supposed to be greater than, this expression is supposed to be greater than 0, meaning that the inequality is describing the product which is greater than 0. And the product which is greater than 0 is a positive product. So, which means that where we have a positive product, we circle the positive product and we tick the range as part of our solution. We circle this positive product and we tick the range as part of our solution, giving us this ticking. As we've ticked the regions, we have the true solution to be what? The set of x such that x is less than -3/2 or x is greater than 2. Answer D. Next question, the range of values of x for which the inequality, this is not an absolute value inequality. The absolute value inequality, 2x minus 3 is less than 3 is solution. The absolute value of 2x minus 3 is less than 3 if and only if, to remove this absolute value, we bring in -3 here and maintain 3 here. So what you have here is being sent backward and maintain and change as negative. If it was positive here, we have -3 less than or equal to 2x minus 3 less than 3, which means that the expression you have here is greater than negative of this value and less than that value. So that is how we remove an inequality sign for a less than case. Now, having this in mind, we can solve this inequality. We can solve the two parts of the inequality at the same time, which means to find the range of values of x, if we want to remove this -3, we add 3. We know that adding the same quantity on both sides of inequality leaves the inequality sign unchanged. If I add 3 here, I should also add 3 here. And solving this at once, I should also add 3 on this side. I should also add 3 on this side. And when I add 3 here, 3 plus -3 gives 0. -3 plus 3 gives 0. And we are left with 2x here. 3 plus 3 gives 6. Now, remember again, this 2 is a positive quantity. To remove a positive quantity as a coefficient, we divide both sides and the inequality sign remains unchanged. Yes, we divide both sides by 2. Divide both sides by 2. All through we divide by 2. Now, 2 cancel here, 1. 2 into itself, 1. 2 into itself, 1. 2 goes into 6. How many times? 3. So we have now that x is less than, what is left is 3, greater than 0. And our answer is V. Question 30. The set of inequalities that satisfy the shaded region is the set of inequalities. Now, the inequalities satisfying this shaded region is, looking at this, you see this line is the line y equals 2x. Now, the part of this line shaded that intersect the side of this line that coincide with the shaded portion is the above part. So if we want to shade the above part, the above part will be described by the inequality y is greater than 2x. Now, as we look in the solution, the inequality y is greater than 2x, you see, is this above part, this part of that line. Now, looking at this broken line, 2x plus y is equal to 4. Now, the side of this line that can be shaded to intersect that shaded region is this below part, which is the inequality 2x plus y is less than 4. This is it, as you can see. 2x plus y is less than 4 if the region below. Now, another line that is not clearly visible and has an intersection too with this region is this side. And if you see me doing that, you see that this is shading the x-axis above, shading above the x-axis, and the x-axis is the line y. The x-axis is the line y is greater than 0. The x-axis is the line y is greater than 0. The x-axis is the line y equal to 0. This line is the x-axis. Now, another one, this is y greater than or equal to 0. This shaded region. Now, another one, this one is, this is the y-axis, and this is the right side of the y-axis, the right side. And this right side of the y-axis alone is the line x is equal to 0. And this positive, this right side is the line x is greater than or equal to 0. So that is why you see this inequality shaded. X is greater than or equal to 0 is this side above. And when you look at it, you see an arrow indicating it, which is this arrow. So it intersects the shaded region. So when you look at this series of inequalities that have just been described, and as in the rough work here, you see that the set of inequalities that satisfy the shaded region is, the first one is x greater than or equal to 0. X greater than or equal to 0. The second is 2x plus y is less than 4. The third is y is greater than 2x. And looking at this series of answers, you see that the answer is B. Only B is directly in line with what we have just done. So we move to question 31. The inequalities that represents the statements y must be almost 3x, y must be almost 3x, and y must be at least 2x. Now, I want us to first of all interpret these terms. Look at the solution. At most means less than or equal to. At least means greater than or equal to. So the key words here is at most, and here is at least. So at most meaning less than or equal to, and at least means greater than or equal to. Y must be at most 3x means y should be less than or equal to 3x. Y must be at least 2x means y should be greater than or equal to 2x. So our answer is A. Question 32. The shaded region is bounded by the inequalities. Y is less than x, y is equal to x, that's the line y equal to x, this line. So y is less than x is this region. Okay, we have y, 4y is greater than or equal to x. 4y is equal to x. 4y is equal to x is this line. And now 4y is greater than or equal to x means shading this region. Okay. Next, we have 2x plus 2y is less than or equal to 12. Now, this is the line x plus 2y equal to 12. Now, we have x plus 2y is less than or equal to 12, meaning that we are shading below this line. Good. Now, within the shaded region, the maximum value of the constraint 2x plus y is, we have just shaded to indicate, please, where the shaded region intersect. That shaded region is actually the region the question is trying to describe. Remember, this is a revision lesson, which means that we are providing detailed solution and explanation to basic concepts. Okay, the constraint we have is 2x plus y. So please, we identify the constraint and we look at the solution. This is the constraint. We look at the solution. Looking at the solution in this shaded region, the required region here, we still sketch it and we identify the points where the different lines intersect. We identify that this point L is 4, 0. This point N is 0, 0. This point M is 8, 2. And now we bring down the constraint. The constraint is 2x plus y. This is the constraint. 2x plus y. And now, how do we know each region? The bounded points are 4, 4, 8, 2, 0, 0, as we've indicated. Now, at the point L, which is 4, 4, the constraint is satisfied by 2 into 4 plus 4, giving us a value of 12. At the point 8, 2, the constraint is satisfied by 2 into 8 plus 2, giving us a value of 18. At the point 0, 0, the constraint is 2 into 0 plus 0, giving us a value of 0. But the question was, within the shaded region, the maximum value of the constraint. Looking at all these three values of the constraint, we see that the maximum, which is the highest value, is 18. Therefore, our answer is Z. Question 33. Given that the functions f and g are such that f is such that x maps to 2x plus 1 and g is such that x maps to x squared, where x belongs to the set of real numbers, then gf will be such that x maps to solution. F of x is equal to 2x plus 1. G of x is equal to x squared. Now, when it is given in the mapping, is expressed as a mapping, we can always take the mapping and we express it as a function of x. And in f of x, in f, the function f, we can find f of x as, we have already seen f of x will be 2x plus 1. G of x will be x squared. Now, gf of x means that we should go to G. We should go to G and we replace f of x by 2x plus 1. That is what we have as indicated by the arrows. Now, when we go to G of x and we replace what? x by f of x, we now further move to express the f of x in what? In g of x. And we know that g of x is x squared. So where we have x squared, x in g of x, x becomes what? 2x plus 1. That is why instead of x squared, you see x taking the place of 2x plus 1. And instead of x squared, we have entirely what now? 2x plus 1 all squared. And 2x plus 1 all squared expanded gives what? 2x plus 1 into, this one is expanded as 2x plus 1 into 2x plus 1. And when you expand, 2x times 2x gives 4x squared. 2x times 1 gives 2x. 1 times 2x gives 2x. 2x plus 2x, that's why you have 4x. 1 times 1 gives 1. So the answer is 4x squared plus 4x plus 1. And we have A as the alternative. Because when you look at this one, you look at the expanded form here, you see that there is no expanded form here that satisfies this. But when you look at A, you see that A satisfies this step above this one. So that is why we say the answer is g of x is such that x maps to 2x plus 1 all squared. Question 34. The function f is defined by f of x equal is a piecewise defined function. 2 minus x for x less than 0, 2 plus x for x greater than or equal to 0. The value of f of negative 2 is, yes, please. Before looking at the solution, whenever you see such a function defined at intervals, you need to evaluate f of any value. You need to identify that value and look at the various intervals to see where that value actually lies. So for f of negative 2, x is equal to negative 2. And we see that negative 2 is less than 0, which means that this value lies in this region. So this is the function that satisfies f of negative 2. Thus, we use f of x equal 2 minus x. And in this case, f of negative 2 will be 2 minus negative 2. And this minus negative gives plus 2 plus 2, which is 4. Answer D. Question 35. Given that the matrix negative 1, 3, 2, 1 is represented by the transformation T, then T is solution. If any given matrix M equal A, B, C, D represents a transformation T, then the mapping T will be given by, look up please, T such that any point xy will be mapped to ax plus by, comma, cx plus dy. Now, in this case, since our matrix M is equal to negative 1, 2, 3, 1, now the transformation mapping defining each point, general point xy, will be given by substituting the value of A, which is what? Negative 1. Substituting the value of B, which is what? 3. Substituting the value of C, which is 2. And substituting the value of D, which is 1. So we have negative x plus 3y 2x plus y as our transformation mapping. Answer C. Question 36. The image of the point 3, -2 under the transformation T, where T is such that xy maps 2x plus y, 2x plus 3y is solution. The transformation T is given by T such that xy, in a point xy maps 2x plus y, 2x plus 3y. For each transformation following the previous question that we've just looked at, the matrix of transformation will be 2, 1, which is the coefficient of y, again 2, 3. That's how we get the entries. Now, in this case, point 2, -2 will be transformed in column as 3, -2, because to multiply points in matrices, we need to transform the points from rows to columns, from the row forms to column forms. Now, the image of the point is given by, this is the matrix. The general rule is that if we have M as the matrix of transformation, the image of any point given by xy will be M into xy is equal to x prime, y prime, where x prime is the image, x prime, y prime is the image of the point xy. So now the matrix is 2, 1, 2, 3. The point is 3, -2. So the image will be obtained when we multiply this matrix. And to multiply this matrix, we take 2 times 3 plus 1 times -2. We have 2 times 3 plus 1 times -2. We have 2 times 3 plus 3 times -2. 2 times 3 plus 3 times -2, giving us 2 times 3 is 6. 1 times -2 is -2. 6 minus 2. 2 times 3 is 6. 3 times -2 is -6. So 6 minus 6. 6 minus 2 is 4. And 6 minus 6 is 0. 6 minus 2 is 4. So answer, the image of the point 3, -2 under T is 4, 0. The answer is A. Question 37. Given that M is equal to 2, 1, 5, 3, then M inverse is solution. Given any matrix M, the inverse matrix M to the -1 is equal to 1 over A times B minus B times C, these diagonals, times the adjoint of the matrix, which is obtained by interchanging this leading diagonal and changing the sign of the other diagonal. This diagonal, we change the sign of the entries. So for the matrix M, which is 2, 1, 5, 3, M inverse will be 1 over 2 times 3 minus 1 times 5 times, we interchange, instead of 2, 3 here, we have 3, 2, and we change the signs of 1 and 5, -1, -5, giving us 1 over 6 minus 5, which is 1 times 3, -1, -5, 2. So the inverse of the matrix M is 3, -1, -5, 2. Answer C. Question 38. The binary operation star is defined over the set of real numbers R as x star y is equal to x plus y modulo 5. Then 3 star 2 is equal to x star y is equal to x plus y modulo 5. This modulo 5 means the answer when x plus y is divided by 5 is just the remainder. This means that to get x star y, you add x plus y, divide by 5, and just write the remainder. 3 star 2 will be equal to what? 3 plus 2. This 3 plus 2 is 5, and 5 in mode 5 means 5 divided by 5. This is equal to 1 remainder 0. So in mode 5, the answer is 0. In mode 5, the answer is 0. So answer A. Question 39. Given that the binary operation star is defined over the set of real numbers R as x star y equal x plus y plus 2, the identity element under the operation is, now x star y is equal to x plus y plus 2. Let E be the identity element. Then for every element x belonging to the set of real numbers, E star x must be equal to x, and x star E must also be equal to x. These two equations, if they are satisfied, it means that this E is an identity element. Now, 1, let's call this one 1. And let's call this one 2. Now, for 1, E star x is equal to x implies E plus x plus 2 is equal to x. Now, we find the value of E. If we subtract x on both sides, we subtract x on both sides first, we have that, please, subtracting x, not 2. If we subtract x on both sides, this x will give 0 with this one will give 0 with this one, and we'll have that E plus 2 is equal to 0. Now, subtracting 2 on both sides, these two go with this one, E is equal to 0 minus 2, which is 2. That is the answer of E for 1. If we solve these two, and we have the same answer as equal -2, then it means that -2 is the identity element. Okay, we proceed. X plus E, x star E is equal to x implies x plus E plus 2 is equal to x. Again, if I subtract x on both sides, x minus x gives 0, x minus x gives 0, and 0 plus anything leaves that thing unchanged. Any number leaves the number unchanged. So which means that E plus 2 is left on this side and 0 is resolved on this side. Now to find E, we subtract 2 on both sides. These two cancel this one because it gives 0. And what we are left with on the left hand side is E. 0 minus 2 is -2. So 2 also gives E to be -2. 1 and 2 implies E is equal to -2. And therefore, -2 is the identity element. Answer B. Question 40. Given that from the operation table, the set A, B, C, D forms a group under star, then the order of the group is solution. The order of any group is simply the number of elements in the set forming the group. In other words, we say it is simply the cardinality of the set to which the group was formed. For the set A, B, C, D, the order is simply counting 1, 2, 3, 4. So order 4. Answer C. Question 41. Given that the vector equation of a line R is equal to negative 3i plus 2j plus t into negative I plus 5j, then the direction vector of the line is solution. Generally, if the vector equation of a line L is given by L such that R is equal to A plus TB, where A, B are vectors, T being any scalar, then the vector B is called the direction vector. Please, in this case, this is a vector B, this is a vector A. For the line L such that R is equal to negative 3i plus 2j plus t into negative I plus 5j, the direction vector given by B will simply be what? The vector multiplied by the scalar t. This is B. This is the vector A. So the direction vector is given by B equal negative I plus 5j. Answer D. Question 42. A unit vector in the direction of a vector A is, how do we obtain the unit vector? Solution. Generally, let R denote the unit vector in the direction of a vector A. Then the vector R will be obtained by taking what? The vector A over the magnitude of the vector A. Answer B. Question 43. Given that U is equal to the vector 2i minus 3j and V is equal to the vector negative I plus 4j, then U dot V is equal to, please, we look at the scalar product of that vector. Generally, for any two vectors, A equal x1i plus y1j, B equals x2i plus y2j, then A dot B will be equal to C, x1 times x2 plus y1 times y2. For U equal to I minus 3j and V equals negative I plus 4j, then U dot V will be equal to, look at the I components, please, multiplied together. The I components multiplied together, 2 into negative 1. The J components plus the J components multiplied together. 2 times negative 1 is negative 2 plus negative 3 times 4 is negative 12. So 2 minus 12 is negative 14. And the answer is A. Question 44. The vector equation of the line joining the points A and B with position vectors A and B respectively is, generally, if A and B are 2 points with position vectors OA equals A plus OB equals vector B respectively, then the vector equation of a line joining the points A and B denoted R is given by R equals vector A plus T into vector B minus A. Answer A. Question 45. D dx of 3x squared is equal to, solution. Generally, d dx of any power function x to the power n is given by the formula n times ax to the power n minus 1. This is the formula for differentiation. That's the formula for differentiation. So d dx of 3x squared, you see that the 2 will come down, multiply 3, and we'll have 2 times 3 into 2 minus 1. this is equal to 6x to the power 2 minus 1, which is to the power 1. 6x to the power 1. Answer 6x. So the answer is A. Question 46. d dx of cos 2x is equal to, now, generally, d dx of cos ax, the cosine function of trigonometry, is given by negative a sine ax. So d dx of cos 2x will be given by negative 2 sine 2x. Answer D. Question 47. The value of x for which the function y is equal to 5 plus 2x minus x squared has a maximum value is, the value of x at which this function has a maximum value is, good. The value of x at which the quadratic function, a general quadratic function, f of x equal ax squared plus bx plus c, a is less than 0, because we only talk of maximum when this value a, like this, is less than 0. Has a maximum value is given by x equal negative b over 2a. Now, please look at a and look at the positions of b. Y equal 5 plus 2a, 2x minus x squared implies a is equal to negative 1, a is equal to negative 1, b is equal to 2, and c is equal to 5, which is the constant term. Now, x equal negative b over 2a is equal to negative 2 over 2 into negative 1. 2 cancel here, 1, 2 here, 1. Negative cancel, negative. So the answer is 1. And please, just to recall that in the above, we said we only have a maximum situation where the coefficient of x squared is less than 0. Here you clearly see that the coefficient of x squared is negative 1, which is less than 0. That is why we can talk of a maximum value, the value of x at maximum. So answer A. Question 48. The integral of x cubed dx is equal to, generally, the integral of x to the power n dx is equal to x to the power n plus 1 over n plus 1 plus k, k being a constant. This is called the general formula for integrating a power function. The general formula for integrating a power function x to the power n. Thus, the integral of x cubed dx, we notice that x cubed is a power function, will be given by x to the power 3 plus 1 over 3 plus 1. Now, 3 plus 1 is 4, x to the power 4 all over 4 plus k. So the answer is C. Question 49. The integral of sine 2x dx is equal to, answer. Generally, this integral of sine nx dx is equal to negative 1 over n cos nx plus k. This is the formula for integrating the sine function. The formula for integrating the sine function. Now, for the integral of sine 2x dx, we have negative 1 over 2 cos 2x plus the integrating constant k. Answer B. Finally, question 50. The area bounded by the curve y equal x squared and the x-axis in the range x greater than or equal to 0, less than or equal to 2 is, please, this region and this curve. Solution. Generally, the area bounded by any curve y equal f of x, the x-axis in the range x greater than equal to a less than equal to b is defined by area equal the integral from a to b f of x dx, which means that once you have a graph that has covered an area,